Here's our warm-up for today. Hope you're ready to start going over it. So we're finding a rule, which means to find an equation that gets you from x to y every single time. Well, a couple things I'm going to look at is that my y's are higher than my x's, which means I'll probably be adding or multiplying. The first one, if I want to figure out the difference, well, if I added 2 to 2, that would give me 4, or I could go times 2. And that would also give me 4. So I'm going to see if either of those patterns work for the rest of them. Well, if I go 3 plus 2, that's not 6, so the adding 2 doesn't work. If I go 3 times 2, that gives me 6, so that looks good so far. So let's keep checking. 4 times 2, well, that's 8. 5 times 2 is 10, so there's my pattern. So I know I'm multiplying by 2. So I'm taking every x, multiplying it by 2 to get to y. So when I write that, I'm going to write it as y equals 2 times my x. And there's the rule. So going over to number 2, this time I notice that my y values are decreasing, so that's going to be important, so are my x's. But again, the table's backwards, but we're looking to see what difference, how can I go from x to every y every time? Well, I start with 7 and 21. Well, to add, since y is bigger, I'd be adding 14 there. Another way to get from 7 to 21 is to times 3. So I go to my next pattern, 4 to 12. Well, if I add 14 to 4, that's not going to give me 12, so that's not going to be it. So we check the times 3. 4 times 3 is 12, so let's keep checking that one. 2 times 3 is 6. Negative 1 times 3 is negative 3. So there's my pattern. Y equals 3 times every x. So hopefully you found both of those rules for these tables. If you didn't write them correctly, then just make sure you add that into your warm-up. Today we're working on chapter 5. Ignore the title here. That's not the title from your paper, which is fine. Yours should say Intro to Chapter 5, Inverse Variations. Once you have those papers in front of you, then unpause the video to get started. So today we're going to be working on variations. We'll have a couple kinds that we're looking at. The first kind is what we call direct variation. And that's what we just looked at with the warm-up, the direct variation. It's when one of the variables increases while the other one increases as well. Now, they don't both have to decrease. They can also both decrease. Basically, they do the same thing for direct. So if x goes up, y goes up. If x goes down, y goes down. They either both increase or they both decrease. The next one, which is not going to be familiar to you, direct should, that's most of your equations and rules. Inverse variation, one quantity will increase while the other one will decrease. Now we say proportionally because we're talking about multiplying and dividing. So like in the rule, the proportionality was times 2 in the first one and times 3. it's consistent. So we're looking for how do you get from every x to every y, whether it's direct or it's inverse. If there is no relationship by multiplying or dividing, then it's not either of these variations. It doesn't mean that there's not a pattern, it's just not specifically called direct or inverse. So our first set of directions say to determine if it's a direct variation, an inverse, or neither. If it's direct or inverse, then we need to find k. If it's neither, then we don't have a k value because there's no proportion. So k is what you're multiplying or dividing by. So in our warm-up, k was 2 for the first problem, and k would be 3 for the second one. So let's get started here. So our first example, we're looking at, do my x's and y's increase or both decrease? So my x's are going up, 2, then 4, then 10, then 15, but my y's are going down, which means this isn't a direct, this is an inverse. Now for inverse, and again we said that x went up and y was going down, so they're doing different things, which is what inverse is all about. To check and make sure about it, their product should equal the same thing. X times y should equal k. So let's check. 2 times 15, that's 30. So if this is truly inverse, they should all be 30. 4 times 7.5 is 30. 10 times 3, 30. 15 times 2 is also 30. So it's for sure an inverse, and our k value is 30. Now let's look at the next. And we're going to do the u-tries together here. Well, the first thing I'm going to look at is, are my x's and y's both going up, both going down, or one of each? Well, my x's are going from 0.2, then 0.5, 1, 2, so that's going up. My y's start at 40, then 16, then 8, then 4, so they're going down. So it's possibly going to be inverse. And it'll only be inverse is if when you multiply x times y, they all come out to be the same thing. So 0.2 times 40 is 8. So all of them need to be 8 in order for this to truly be an inverse. 0.5 times 16, well, that's like half of 16, so that's also 8. Ignore the decimals because we just have 1 times 8, which is 8. And then 2 times 4, which is also 8. So since they're the same, just like in the first one, we know that it's an inverse, which means we can state k, which in this one is 8. Going over to the third one. First, I look at my x's and y's. My x's are going down, 7, 5, 3, 1. My y's are also going down. So this will be direct if they have the same pattern. So since they both go down, it's possibly direct. Well, 7 times what is 42? And if you don't know that, you could also think of this as 42 divided by 7. And that's 6. So we need all of them to divide to be 6. So 30 divided by 5 is also 6, so far so good. 18 divided by 3 is 6. And last but not least, 6 divided by 1 is also 6. So since they're all the same, and they both went down, or they could have both gone up, this is direct, and the k value is that number that's all the same, which is 6. So let's talk a little bit more about inverse variation. When you multiply your x and y pair, which is what we did in the first two examples, that gives us k. Now, when we need to solve for an unknown, we're going to plug k along with the value that we know into this equation. And it's going to be y equals k over x. Now, you're going to ask me, you're going to say, but wait, we multiplied to find k. And you're right. But now we're solving to find either an x or a y, which means we have to do the opposite, and the opposite of dividing or multiplying is dividing. So once you find k, you divide by either your x to find y. So let's look at our first example. Now, here's where it's very important. Notice how we have the statement x and y vary inversely. When we have that statement, we know that we're going to go steps 1 and 2 under inverse variation. If it didn't say that and it said direct, well, then we're looking for that rule like we did on the warm-up, figuring out what number they're all multiplied or divided to get to. So, first thing we have to do is find k. So to find k, we multiply x times y. Well, x is 4, y is 12, so my k value is 48. Step 1. Now the question asks us, what is the value of y when x equals 10? So now we plug it into that equation up here in order to find my unknown. But we had to do this step first in order to find k. So we're going to go y equals k, which is we found was 48. We're going to divide it by what x is now, which is 10. And 48 divided by 10 would be 4.8. So again, keyword was inverse or inversely. We first figured out what k was by x times y, and then we used the second part of the problem because that had the unknown into it, the value of y. So go ahead and do your you try. Check with each other once you find k and then once you find y. So all of these you'll have to find two things, what your k value is and then what your unknown is. Unpause this when you're ready to check your answer. So again, our key phrase here was vary inversely. So we know that to find k, we're going to multiply x times y, which in this case would be 8 times negative 7. Hopefully you caught that negative next to the 7. Well, 8 times negative 7 should have given you negative 56. So step 1. But the question doesn't actually ask us what k is, it asks us what a y is. So we go to the equation since it was inverse, y equals k over x. We don't know y, so y stays y. K has become negative 56. X is now 2 because we're figuring out a different ordered pair. And when you divided negative 56 by 2, you should have gotten an answer of y equals negative 28. And there was your answer. Well, if you flip your notes over, we have a couple more variations to talk about. We have combined and we have joint variation. Combined variation is when a variable varies with respect to two or more other variables. So with combined, we're just putting multiple variables together. They could be put together by multiplication, like k times x or w times z, or we could also have division in there. So combine just simply means you're not just multiplying two things together, dividing, you have a combination of them. Now, anytime we see the word variation, that means we're going to have to insert in a k. K is a constant. It is always part of a variation. It won't tell you that it is, but it always is. Joint variation is when one quantity or variable varies directly with two or more other quantities. With joint variation, you will have that k because of the variation part, and we're going to be multiplying. So joint variation is this top part here, the k times v times w. When you insert the division, that's actually using the word inverse, or inversely. And think about your formula for inverse. It was y equals k over x. So joint means you're going to multiply them together. Inversely means that you're going to divide. And combined variation just means you have these multiple variations going on. So using a combined variation, we're going to write the formula, whether you're multiplying or dividing, based on the word problem. And again, we're looking for words like joint and inversely. We're then going to substitute in given values. And the first thing we're going to solve for is k, just like we did with inverse on the front side, where you had to find k first before you could do anything else. That still applies no matter what type of variation is going on. And then we're going to solve for the unknown by substituting other known values along with the k that we just found. So it's exactly what we did on the front page, except for we're going to have more variables here. So our first problem says the number of bags of grass seed N needed to reseed a yard varies directly. Well, directly means we're going to multiply. It would have said joint there if there was more than one variable. A to be seeded, and inversely. Inversely means we're going to divide with the weight W of the bag of seed. And then that's going to be our first part. That's going to find our k. Then we will use the rest of the information. So we need to write our formula. So it says we're finding the number of bags of grass seed. So that's N equals, and now because we had words like inverse, direct, we have to insert in k. Since our first word was direct, that means we're multiplying k by something. And we're multiplying it by the area, which is A. Then we ran into the word inverse, which means we're going to divide, and we're dividing by the weight, which is W. So now we're going to start using the information to find k. So it says that we have 2 bags, so that's N. K is going to be our unknown. Then it says the area of 3,600 feet. So that's A. And we're dividing it by the weight, which they said was 3 pounds. Now, a couple of things here. First of all, I'm going to rewrite the k times 3,600 as 3,600k. And now I need to get rid of this divide by 3. Well, the opposite of dividing is to multiply, and if I multiply on one side, I'm going to multiply on the other. So this really becomes 6 equals 3,600K. And we're then going to divide both sides to get K by itself. Go ahead, 6 divided by 3,600 should give you a repeating decimal of 0.0016 repeating. Well, the question says, how many bags to seed 9,000 feet squared? So now we're going to actually answer that question. We had to find K in order to do so. So we're going to go N because we need to know the number of bags equals, going back to my formula here, well, K we just found was 0.0016. We're just going to go ahead and just use that. And it says the area is 9,000 feet. And our weight of the bags is that 3 pounds. So now we're going to multiply 0.0016 times 9,000. So now you should have that N equals 14.4 over 3. Divide it by 3 gives you 4.8. So now the question is, how many bags? Well, can you have 4.8 bags? No, they're not going to let you do that. To take 88.8 of a bag. Could you seed it all with just 4 bags? No, you'd have a little bit left that you still needed to seed. So you would have to buy 5 bags. So now you have your you try to work through. Treat it just like we did with the first problem. Now notice here it does say to vary jointly instead of directly. It's the same thing. You're just going to be looking for more variables. So let's go ahead and write the formula part ourselves together, and then I'll let you finish the rest. So we're looking for the number of bags of mulch. So there's N. Varies jointly. Well, anytime I see that vary word, I need to insert in K. Jointly means we're multiplying. And we're multiplying it with the area to be mulched, which is A, and the depth of the mulch, which is D. Reading through the problem, do you see the word inverse anywhere? Nope, which means we don't have any division here. So this is your formula. So now go ahead, remember, first find K, and then replace that in with the other information to find your number of bags. Feel free to work with the neighbors as you go through this, and then unpause this when you're ready to check it. So to find K, we're going to use the 10 bags with 120 feet squared and the depth of 3. So 10 bags, which is N, equals K, because that's always what we try to find first, times the area, which is 120, times the depth, which is 3. And there is a typo here, so let's go ahead and fix that. This should be in inches, not feet. So let's go back to the problem. So now we have 10 equals K. Well, 120 times 3 is 360. So to solve for K, we're going to divide by that 360. So K should equal 0.027 repeating. So now we use the next part of the information to find the answer. So we're finding the number of bags, so n equals k, which is your 0.027. The formula then talks about area. Well, it's 200 this time. And then d for depth, which this time is 4. So we can just simply multiply this straight across, and you should have gotten n equals 22.2. And it probably repeated, or you had several 2's there. Well, once again, can you buy 0.2 of a bag? Nope, store's not going to let you do that. You can't just buy 22 bags because you would still have a little bit of area that you didn't get mulch on. So you need to buy 23 bags.